Hey YouTube, 7 a.m. So a quick video before heading to work. Um, Today's project is gonna be about this thing. I use it for all my projects. It's a MIG welder, runs off of Makita batteries. As you can see in the handle, there's two Makita battery holders in there. Handle is just folded aluminum sheet with a piece of tube welded on top. In the handle, there's a positive that goes to the tip of the gun, so just a simple wire, and a negative that goes basically to the earth port here, and there's a gas hose. So that's all there is to it. If you make one yourself, you would want to put a small diode across the motor, because back EMF might kill your cheap $2 AliExpress PWM converter, but nah, there's very little risk, but it's a good small improvement to make, because there's no real filtering on the output of that PWM controller. You'll find the links to all the parts in the description. Personally, right now, what I would change to this thing is I would use the little Parkside 8 amp hour batteries. In Europe, they're really cheap. They use 21700 cells and they can provide quite a bit more current. They're also just a lot cheaper than Makita, and the electronics don't really get in the way of welding. There's a benefit to this. It just doesn't break as easily, and there's a downside to this, is that you don't get the low voltage protection. But I don't think you need it that much if you're just welding casually. So that's today's project, and I'm gonna show you the workspace I used to build it. I'm gonna show you how it looks like and what I've iterated from over the past few years, because I think I've been fixing my own stuff with this and helping others with it for like 6 or 7 years now. Um, and it's just because it's so much quicker. Like, if you have to take your car to the garage because something small breaks, and instead of doing that, 30 minutes drive there, 30 minutes drive back, you lose the thing for a day and you need the car to drive to work. If instead of doing that, you can spend half an hour fixing it, it's so much more efficient. So that's usually what I do. So that's why I have like this kind of stuff. It's also because I live in the Netherlands, so I live in a small space, and because of living in a small space, it would be hard to fit like a whole MIG cart in here. This is just much more practical. You can carry it around. You can fix stuff on the fly, basically. So that's sort of a summary of the why and how. And yeah, I'll show you guys around, show you the workspace, and show you how I came to basically this design. So one of the things I really tend to use a lot is a welder, and this is a basic MIG welder. The handle is from AliExpress, so is the what's in the handle. This is actually a PWM motor controller. This is a step-up converter, and this is not from AliExpress. This is from a German company. It's a small gas valve, so that if you feed argon into it, it will only turn on the gas flow if you press the trigger, which is rather handy. This is the first evolution of this MIG gun, and what I've done with this is I've used a relay so it can switch any voltage, and a battery power supply on the back with just 18 650 cells. So with those battery cells, basically I step up the voltage to somewhere close to 24 volts. Just close this up, and then use that to feed the motor in the gun, and use that to switch the relay on and off. So this is sort of the first iteration. It will run off of basically anything. I will put the parts in the description, and you guys can just check it out. This is the power supply I use. It's a cheap Chinese welder, ZX7. What I've done with the amperage control is I've actually modified the display slightly, so I've used a voltage divider there. I think I will show you guys soon how that works, but what's going on here pretty much is that this thing doesn't really put out 250 amps, it's more like 120-ish. So what I've done is I've just made the display reflect how much current it is put out by this thing. So this display is actually controlled by a voltage, 0 to 5 volts. So if you just put a resistive divider in here, which is 3 resistors, not that much work, you will get accurate current reading. So I'll show you guys that. Just take it over here, plug it in. So here you can see sort of the accurate amperage it's outputting. I've also, of course, added the Anderson connector on the top, so it's easy to plug the MIG gun into it. So if you have the MIG gun right here, connect the battery. You give it some wire feed. Well, that's the very basics of how this works. I'll take it apart next. Then you guys can actually see how it's assembled. Yeah, this is what I used for quite a while. Nowadays I use something different, and I'll show you that next. But first I'll just sort of explain how this works. So what happens when you pull the trigger is, of course, a wire comes out. In this case it's a soft aluminum wire, because I've used this to weld aluminum before. It's a spool gun. That's also actually why I use a spool gun. Aluminum wire tends to ball up, and I've had a big MIG machine before. They're horrible for welding aluminum. These things are just so much better for that. So MIG welding basics: you have a ground, you have a connection to the electrode, which is the wire coming out here. So you clamp the ground to some workpiece. The wire comes out, hits the workpiece, short circuits the current between this tip and the metal piece, and basically it heats up and you get a weld. That's sort of the MIG welding basics. Then you have a gas. In this case, the gas connector is here, and you use that gas to avoid all the heat oxidizing the metal, so you get a neat looking weld. That's sort of the basics of this MIG gun. Next we'll go over the one I currently use, and also the gas bottles I use to work with it. So this is the welding gun. We'll just take it apart. I've taken the time to unscrew a few of the screws, and you guys can see what's actually in it. So it's quite crowded in there. Here you can see the small PWM converter that actually feeds into the motor here, and you can see it's well used. Like, this has been used outside a lot. Here you can see the small gas valve going to this tube, and they actually, this was a perfect fit because the outlet on these small gas valves fits exactly into this tube, so that works really well. I'll link the components to you guys later. Here you see the power cable. This is the small power supply in here. Same thing is there. In the later version of this, there will actually not be that power supply because we're gonna feed it off of Makita batteries. So yeah, that's the innards and sort of the how to build it. This is a first version and I've used it a lot, and yeah, it just works and it keeps working, and it will basically use any sort of voltage. Only modification I've made to this handle is there were some plastic pins in here, and just to make some room for the converter I've had to grind those out. It's the only real modification to the body of the gun that I've made. So this is the gas bottle I use for MIG welding. As you can see, this one says 99% argon. So that's what's in it. It has a basic hose connector. You just clip it on here. So this goes in here. Just grab that properly. It's kind of difficult to do one-handed. Okay. So now there's a gas connected to the MIG gun. Here you have a pressure gauge, also off of AliExpress, which tells you how many bars are still in the tank. This is a paintball regulator, and you can actually set it to 0 to 150 psi. I use it to control the flow rate, because in here is a rather small hose through which the argon goes. So if you control the pressure, you control the flow rate. And this is basically a bit sturdier knob I've made onto it. So you can see that's how you open it. Let's turn the wire down. So you can hear pretty much the gas escaping if you hit the trigger. This is the first version, and I'll show you the one I use currently next. First we'll take this apart so I can show you guys how to assemble one. It's really rather basic. It's AliExpress MIG gun, and yeah, does everything you need right there. So that's how to DIY a MIG welder, I guess. So here we have what I typically use. This is the current version of the welding gun. It's stuck here in a crate with pretty much everything you need. Chinese welding goggles. These aren't for welding a long time, but they work fine for short stints. So this is essentially what I use to weld. This has sort of the same components as that one, except this little boost converter, because this runs off of 20-volt batteries, and the motor in this thing is a 20-volt motor, so it's actually slightly simpler than that other one. You can just hook it up to a Makita battery. So the only real main difference is that there's a aluminum base with gas connector and a ground port. It's just a small folded welded aluminum base. That's it. That's all you really need to MIG weld. You need some power. In this case, 2 Makita batteries. And you need a spool gun. So that's the entire thing. And next I think I'll show you guys how this welds. And well, since we have the gas bottle and the ground clamp and everything here, might as well hook it up. So this is how the entire setup looks when it's connected. So you have the gas bottle here with the valve already open. You have the hose. It's a silicone hose because silicone just doesn't burn as easily. Same for the wire, silicone coated wire. So if any heat gets to it, that's not gonna cause any problems. Argon tank, paintball regulator, and just, yeah, small piece of welding material. I'm not gonna demonstrate that much because we're indoors and I'm just, going out in the field next week. I think I'll take a video of me welding there in the field. Now I'm just gonna show you like how does this work and like what's the basics. So welder, basic 5 amp hour Makita batteries. It will run off of that. These are actually 21700 batteries. They're slightly bigger. I used Parkside cells to build these. They work a bit better. They provide a bit more current, but that's not needed when you're just welding like normal metal, whatever, with 0.8 millimeter wire. It'll work fine off of the 5 amp hour batteries here. If you really use it aggressively, you might blow a fuse in the battery, but you can just solder those over. They're on the PCB. I'll show you sometime where to find them, and then you can modify your own Makita batteries. But that's only happened to me once or twice, and that was when I was using bronze wire, which draws a lot more current. So as far as current control goes, there is none. Most MIG welders will provide around 20 volts, which Makita batteries are obviously ideal at. And the current is sort of always limited by the wire you're putting through. So the wire diameter and the feed speed. That's in a normal MIG welder. It's also it's constant voltage, and the current is just dependent on that. So that's why it's actually ideal to build a MIG welder off of basically power tool batteries, because they will provide a lot of current at a constant voltage. So here you have basically the general welding setup I use. You can use these big 21700 batteries, but for now we're just going to use these mostly full standard Makita batteries. So just shove them into the handle. Since this is just plain metal, I'm using argon CO2. I've done some welds before on this plate, and these were with argon because I forgot to swap the bottle. This is with argon CO2. There's a massive difference in just the quality of the weld. This is why you should never forget to swap your bottles out, guys. So you just grab the hose, connect it here, turn on your gas, and you've got the ground clamp. Ground your workpiece. So yeah, standard spool gun, running some standard high carbon wire. It's always sort of issue with birds nesting in there or whatever. I don't care. Let's just shove it in there. Pretty sure it'll work. Grab the AliExpress welding goggles. I'm not gonna do much welding since we're indoors. I'm just gonna do enough to do a small demonstration. So you can hear the gas, that's working. That's pretty much it. This is the bead I just made. So you can see this welds quite well with just 2 Makita batteries. They're standard 5 amp hour batteries, and didn't change anything there. So yeah, battery powered welder. So I promised you guys to show you where the fuse is located in these Makita batteries, so you can see how to bypass it if you want a little more current for the welder. So for this you need a torque screwdriver, and it's actually a security torque, so there's a little hole in the tip here. You can see it on the package. So You need a security torque screwdriver for this. You just open the battery. Here you have the PCB. Let's let the camera focus here. And over here you have a small fuse that bridges from here to here. And basically, if you need this battery to output a bit more current, these are limited at 90 amps. So with two batteries you can still get 180 amps, which is more than enough to weld with. But if you need a bit more, you can just remove this fuse and put a piece of copper over here with a big soldering iron. So that's sort of how these batteries work. So here's the current sensor. These are current sensing resistors. This is the big MOSFET, like a really low RDS on MOSFET, which if the battery gets under voltage or there's some kind of error condition, this MOSFET will turn your battery off. AliExpress PCBs with good MOSFETs on them also exist, but original Makita batteries tend to be a bit better. Yeah, so what you see with the Makita battery is it can definitely output about 90 amps, and that's a lot. But if you have a battery holder like this from AliExpress, like the pins here and this will definitely heat up if you use it at more than 40 amps, 35, 40-ish amps for a long while. So for welding, this is perfectly fine, because if you draw 90 amps for like a minute, it's not going to heat up any, it will just work. But if you say draw 40 amps continuously from these batteries, like you're using it for an induction stove or something, and I actually have an induction stove that powers off of these, and I have an induction heater also that I use for heating metals that I power off of these batteries. And the thing is, like, these pins will definitely get hot if you draw more than 35-ish amps through them continuously. For a welder though, that's no issue, because with the welder you draw a lot of amps, but for a very short while usually, and then you're back to preparing your work. So that's sort of how these work, and now you know where to solder over the fuse. And if you happen to blow a battery or something, that's usually what breaks, like the fuse will just blow open, and then the battery will not provide power anymore. So that's sort of how you can mod a battery. As you can see, like, I didn't modify these at all. I'm just running standard Makita batteries, and that's good enough for me. So that's a current sort of welding setup I use for MIG welding. Really basic, not that expensive. It's just stuff from AliExpress, but there really are some nice welds to be done with this.